Hello friends, this is Rupesh and I'm watching CPP Nuts video series on design patterns, and this video is about thread safety in Singleton Design Pattern. And this is very important. People nowadays ask this question in interviews. Even I ask this question in interviews. And I expect some sensible answer, not exactly this, but something. I mean, at least that guy should be knowing what is the problem with the Singleton if it is not thread safe. So before this video, you should be knowing what is Singleton Design Pattern before actually going to this full video, because I'll be assuming that you already know. This video is sponsored by Dev C++, a fast, portable, simple and free C and C++ IDE and code editor for Windows. Dev C++ uses MingW GCC as its compiler, and it can also be used in combination with Cygwin or any other GCC based compiler. Dev C++ have low memory footprint because it is native Windows application and does not use Electron. And it is immensely popular due to its light footprint, yet giving you all the features you need, not to mention that it's free. So download the latest release for free by clicking the link in the description. So Singleton Design Pattern. We have this Singleton Design Pattern. This is how it look like. We have this instance object, which is actually going to be treated as a single object in your whole system. And this is your static method. It will give you this instance by instantiating this class, assigning that to this instance, and will return to you. So this is the fairly simple program, and don't miss this private constructor kind of thing, because now you cannot instantiate this class. You have to call this by some static way. So you should be knowing that. Okay, let's come to the safety now. So I'll explain you what do I mean by, or what is the actual problem with this thread safety thing here. So just assume that there was nothing, no program, nothing was running. And then we have two threads simultaneously running and trying to get this. I mean, call this getInstance, T1 and T2. They both call this, no problem, they can call, but they call this also at the same time, no problem, they can do that. But thread 1 executed this and there was a switching, meaning it went off. Now it's not running, but it did executed this. So it knows that, okay, what is the value? So it knows that, okay, I got positive result because this instance was not initialized in the beginning, so is equal to null. Yes. After checking that, this thread goes off, it is switched, and T2 also did the same thing. It compared these two and it was true. So for T2 did executed this statement and it initialized this instance variable for us, and then happily this was returned. And after some time, this T2 is back now, and this T1 is back now, which went to context switch, and now this is back. So as I said, it knew that the result is true. So this will also come and execute this one. Now you see the problem? Yeah, we have two instances of Singleton Design Pattern in our application, which is not good. So this is actually a problem. Now let's go for the solution. So the approach 1 to this problem is like you can straight away go and use mutex lock and unlock right before actually checking this condition, because this was creating the problem, right? So you did apply this mutex here. I'm not writing mutex and all, otherwise it will become very lengthy and it will be not useful, because this is not the class how to write mutex and all. It's just the idea that you will lock your mutex here so that no thread can go. I mean, not at least without locking this. So only one thread will be allowed to execute this piece of code, which is critical section. And then you will unlock that. So this is pretty clear that we have solved that problem, but we introduce new problem, that is performance is not good, just because whenever you will call this, or 10 threads will call this, like 10, and they all will have to lock, unlock, and this is kind of a problem. Even if you don't have any threads, like if you are running in a single threaded environment, and then, mostly this will be accessed in single threaded environment, there can be different threads later on. So if you are using combination of single thread and multi-thread way, then if you think that for some instance you have only single thread, then this is totally waste, right? Because you are locking, and this is very costly process. It has to go to OS and some stuff And then similarly here. So this is good. I mean, this is what pretty clean and neat example, what people generally think, but it has some performance issues. So let's go for another approach. So this is another approach. This is called eager instantiation. This is, I would say this is kind of my favorite because I don't care about this problem much. Nowadays we have very big RAM and all that, so we don't have to go for that level of optimization. Okay, I'll explain what I'm talking. So this eager instantiation is like when you are running your main. So just you got entered here, right? That time you are single threaded application. I mean, your application is single threaded. After this main starts, you do something here. I mean, inside main to start your threads and all those things, right? Why not just create this instance? I mean, even if you don't need this, you can call this my singleton get instance and have it somewhere. And then you go and start n number of threads. I don't care, because it is so sure that this condition is never gonna get true when these threads will call these functions, because we already called once and we have already made this instance available. So this condition will be always false for these thread. So this is pretty clean example, but the problem with this is we have lazy instantiation missing. Lazy instantiation is a way where you tell that whenever I need some object, only then and there I will create that object. Otherwise, I won't waste my resources. And why it is considered good? Just because you're not dealing with small object or the construction of some object is very simple. No. Sometimes some constructions of the objects takes so much time, and that time this lazy instantiation makes sense. But if it is like maybe fractions of seconds or at least even lesser than that, then I don't think this makes sense, and then this approach would be very good. But then it depends on you, like what do you want? This is like somebody would see that, okay, you have created this but you're not using it, and what is the purpose of this? Maybe somebody can remove this from your code. So you have to write bunch of comments like don't remove this statement, otherwise whole world will collapse or something like that. So that people will be like, okay, leave this piece. Yeah, so this is second approach, which is still having some problem. We can see that. Now let's go to the third one, which is not having an issue. So this is the one, and this will overcome both the problems what we saw in previous one. First problem was performance issue because we were always checking the lock before actually checking this part, and because of that we ended up doing eager instantiation. So eager instantiation was having another problem, which was lazy instantiation was not there. So this solves both the problems. What we did, we checked even before the mutex lock. So if you will see the previous one here, we were just always coming into this function and applying the lock without actually even checking whether this was initialized before or not. But now here we are not directly locking. I mean, threads will not be allowed to directly lock and wait. First, those threads have to check whether this instance is already initialized. So this way we solve both the problems, performance and lazy initialization. So this is like a big thumbs up. You can go for this. And so many people, I mean, I checked on the internet and they are saying that even this is not good option because it doesn't support each and every operating system out there. But then if you're working on some specific operating system, you might be knowing that, okay, this won't work. But this is a general solution. So I would say that anyone would be happy if you give this answer to them. So with this, I'll sum this video. Thanks for watching, guys. Bye bye. Take care. I'll see you in the next videos.